So I'm going to start with talking a little bit about the financial part of the model. So as I mentioned at the beginning, you can think of SAM conceptually as in two parts. There's a performance model that calculates the output of the system, and then there's the financial model that calculates the cost of generating electricity or thermal energy in the case of the solar water heating model. So I'm going to start off with talking a little bit about the financial side of the model. I will, to do that, I'm going to walk through the steps of modeling a commercial PV system. So I'll start a new project. So I'll go on the File menu, click New Project. I don't need to save the file that I've been demonstrating here. So when you click File, New Project, SAM displays this window, which we call the Select Technology and Market window. And under Technology, this is a list of all the technologies that SAM can model. And I'll go through all of these later on today. But we're going to model a PV system. And so for the PV model, we have two options. One is component-based models, and one is PV watts. So these are basically two different ways that you can ask SAM to model your PV system. And the component-based model is a more detailed approach to modeling PV systems, and the PV watts model is a less detailed approach. So I'm going to start with the PV watts model. And then, so once I choose an option under Select a Technology, then the next step is to choose a financing option. And we're going to look at the commercial market option. And under commercial market, I have three options. One is for cash, so this would be for a system that was financed without a loan, where the owner pays the full installation cost, standard loan, and then third-party ownership. Third-party ownership is a system that is operated sort of under an IPP structure, which I'll discuss later. So for this example, we're going to model a commercial project with a standard loan. So for any project that you're modeling in SAM, the steps are the same. You select a technology, and then you select a financing option, and you click OK to set up the case. And then I need to give the case a name, which I will label Commercial PV Example. I'll just call it Default. So now SAM is opening or creating the file and populating all the input variables with values that are appropriate for the commercial PV system. So you'll notice a few things here. One is that on the, the information bar at the top of the window here, the technology that I chose, PV watts and financial option, are displayed in brackets. So that's a quick check that I set up what I intended to. If I wanted to change these options, I could click Select Technology and Market, and that reopens this window, and I could change the options here. And then by default, SAM displays the system summary page. You'll notice that all the values here are blue. So these are all values that SAM has taken from other input pages. This is just a quick summary of the system, but you can't specify any values on the system summary page. Another thing that I forgot to mention is that on each of the buttons in the navigation menu here displays a little summary of the inputs that are on that page. So the climate button here shows us that we're modeling a system in Phoenix, Arizona, and it displays the latitude and longitude and elevation of for Phoenix from the weather data. We can also see that there's a 30-year analysis period. There's a federal ITC. So these buttons also give you a quick summary of your project. You can't edit the values on the buttons. These buttons are just, the values here are read from the input page. So the climate input page is where I choose the location. So we've got a commercial system. It's a 250 kilowatt system in Phoenix, Arizona. And it has a total cost of install cost of about 3.7 cents per watt. That's the installed cost. And we're assuming that this is a 30-year project with these key financial parameters. If we run the system as is, so I'm just running the default case, I didn't change any inputs, then we can see that the 250 kilowatt system generated 398,000 kilowatt hours in 1 year, and that the cost of energy for the system was about 14 cents per kilowatt hour, and that it has a payback period of about 8 years, a little more than 8 years. So this is typically how you would get started using SAM, is you would set up the type of project you're interested in, and then you'd have a project all with inputs and results already set up for you to review. And then the next thing, I would spend some time looking through all the input pages to familiarize yourself with the inputs. In this example, what I want to do is just see what happens if I change the project location to a different place. So this one is for Phoenix. I'd like to compare this case to the exact same project using weather data from Portland, Oregon. To do that, I'm going to create a copy of this case. So on the case menu, I'll click Duplicate. And then I'll rename the case to make it a little easier for me to see what's going on here. So I just click Case, Rename, and I'll call this one Portland. And then on the climate page, I will choose the weather file for Portland. These are organized alphabetically by state in the U.S. So Portland, Oregon. And I clicked Run. And now by switching between the tabs, I can compare the annual energy for Phoenix was 398 kilowatt hours, and in Portland it goes down to 256 kilowatt hours. So we know that Portland is less sunny than Phoenix. So intuitively that makes sense. This is telling us, by how much we could expect the energy on an annual average basis to differ. Then I can also compare the LCOE. So for Portland, it's 21.3 cents per kilowatt hour, which is quite a bit higher than the 13.7 cents per kilowatt hour. So we can see how only changing the solar resource changes the cost of energy of the system. And the payback period, we can also see it goes from 8.3 years to 16.9 years. So that's an example of using cases to compare two different analysis scenarios. So I might want to, the next question that might come out of this kind of analysis is, well, is there anything that I can do to make the Portland system a little more cost competitive compared to the Phoenix system? So there, what I might do is go to start looking at the cash flow table for the two cases, because this is where I can see some of the detail to compare the two cases. So for starters, I suppose I could start. I should show you the cash flow graph. So if you're looking at the results page in the View Graphs and Charts mode, and choose the after-tax cash flow graph, I can compare the overall cash flow for the two projects. And by switching between the cases, I can quickly see the difference between the two. Negative cash flow represents outlay for the project, so we can see this large negative value in year 0. That's the installation cost. And then these positive values are due to the maker's tax depreciation, or maker's depreciation benefit that these commercial projects qualify for. And then the remaining negative values, these are the cost of debt throughout the debt period. So we have a 30-year project, and that's because on the financing page we specified a 30-year analysis period, and then we have a 15-year loan term specified on the financing page. So these are inputs. You can change these values to whatever you like, and the cash flow graph here then shows us how that impacts project financing. So we have debt through year 15 of the project, and then once your debt is paid off, then the revenue from electricity sales come in as positive values of the cash flow. So one thing we can do is just by looking at this cash flow. So this is the cash flow graph showing the after-tax cash flow for the project. If we switch over to the base case cash flow table, the after-tax cash flow is this row toward the bottom of the table. So these are the values that are being displayed in the graph. But I can see the detail of how this, the numbers that contribute to the after-tax cash flow in this table. So I can't see this detail in the summary graph. If you want to learn more about how this graph, how the cash flow model works, under the Help menu, the Financial Spreadsheets option here displays a list of spreadsheets. So these are spreadsheets that are distributed with SAM. If you click one of these, if we click the commercial loan, we're modeling a commercial loan system. This is going to open an Excel worksheet that mimics SAM's calculations. So the values in this worksheet are not from your analysis. This is a separate workbook. But what this does is allow you to trace through that cash flow table and see the formulas that are used to calculate the values in each of the cells. So if you're trying to understand SAM's cash flow model, these spreadsheets are a really useful tool. And again, they're under the Help menu, and there's a spreadsheet for each of the financing structures in SAM. So for this Portland case, what we can do, experiment a little bit with the financing assumptions. So we see that the debt fraction here is 60%. We could try changing that and rerunning the simulation to see how that affects our metrics. So increasing the debt fraction is lowering our LCOE. So we may need to use a slightly different financing structure in a place with lower solar resource if we're trying to come up with a cost of energy that's comparable. So this is the kind of analysis that you can do in SAM. So what I'm doing here is sort of changing values and then running the model and looking at the results and then going back and changing the values again. To do this, you have to make notes of the values in a notebook or maybe in an Excel spreadsheet separately to keep track of what's happening as you change inputs. What I'll show you a little bit later today and in more detail tomorrow is the parametric simulation option, which is very powerful and allows you to assign more than one value to an input variable. So instead of typing in 80 and then 85 and then 90 and running after each one of those values, I could specify a range of values and then generate a table in SAM showing the how the payback period, for example, depends on debt fraction. Pause for a moment and see if there are any questions.
To ask a question, please press star then 1. To withdraw the question, star then 2. Once again, for any questions, star 1.
So here's a written question that I'll answer now. Do debt payment values in the cash flow include interest? And the answer is yes. You specify an interest rate on the financing page. This is the loan interest rate, which is 8%. And if we look at the results, you can see the interest amount in the base case cash flow table. The annual interest payment amount is actually shown in the cash flow table. Got a question by phone? Feel free to ask it.
Once again, that's star 1. We do have a question from Jonathan King.
Okay, go ahead, Jonathan.
Looks like he pulled his question. Just one moment. We do have one more. Bernamov.
Hi, I was wondering if your model accommodates for feed-in tariffs. I saw options for tax incentives and grants, but nothing for feed-in stuff.
Okay, thank you for the question. There are a couple of ways to look at feed-in tariffs in SAM. One is if from the policy perspective, if you're trying to determine at what level to set the feed-in tariff. And the other is if you're a project developer or looking at it from the project's perspective where you want to model the project financing with the feed-in tariff. So you can model the feed-in tariff on the payment. So in the latter case, where you're looking at it from the project's perspective, you can model the feed-in tariff as a production-based incentive on the payment incentives page. And you can model up to 4 different categories of production-based incentives. So it doesn't really matter from SAM's perspective how you assign the incentive. You can call it a federal incentive or a state incentive or a utility incentive. Then the incentive gets reported in the cash flow table in one of those categories, but mathematically they're all equivalent. So you could specify the feed-in tariff here and specify the amount in dollars per kilowatt hour, and then if the feed-in tariff only applies to the first few years of the project, you can specify the term and an escalation rate if the incentive increases over time. In the first scenario where you're trying to determine at what level to set the feed-in tariff from a policy perspective, then you could just specify all the project costs and financial assumptions, run the model, and compare the feed-in tariff or look at the nominal LCOE, and your feed-in tariff would need to be set to cover that cost in order to be an attractive incentive, or some portion of the cost, depending on what your policy goals are. There's a question here about the nominal LCOE and the real LCOE. There's a mathematical explanation of the difference between the real and nominal LCOE in HELP, and I'll leave you to read that. But I'll give you sort of a qualitative explanation of the difference. The nominal LCOE is the value that most people are used to thinking of when we talk about the cost of energy, levelized cost of energy of a project. So it's the cost of producing electricity over the 30-year project or over the analysis period, accounting for installation costs, operating costs, financing costs, incentives, and the amount of electricity that the project generates. So it's the cost of producing electricity in cents per kilowatt hour. The real LCOE is a slightly different way of calculating the same value that's used by the U.S. Department of Energy. So when you see LCOE values from the DOE, they tend to be in real values. And the difference between the two is how inflation is accounted for in the two versions. Here's a question about default climate inputs for international locations. I'll talk about weather data here shortly. I won't answer that right now.
We do have another question on the audio lines whenever you're ready.
Okay, go ahead.
Wondering how you print things out.
Okay, great question. You can, if you want to print results out, you can use one of the methods that I described to export the data. Generally, right-clicking graphs throughout the interface gives you the shortcut menu, and you can choose an option to, in this case, we're export an image of the graph, and then you can paste it into your document, or you can export the data itself and paste it into a Word document or Excel spreadsheet and print it from there. You can't print things directly from SAM, so you have to export the data to another program to print.
Okay.
Any other questions by phone?
Not at this time.
Okay.
Just a reminder to press star 1 if you would like to queue up on the audio lines.
Okay, I think I'll close the question and answer session for now and answer this last one, which is when you change the location of a system on the climate page, does the orientation of the array change automatically? And the answer is no. Although there is an option on, so if we're talking about a PV system, and when you go to the PV Watt Solar Array page, when you're using the PV Watts option, there is this force tilt equals latitude option, and if you check that box, then SAM will populate the tilt variable with the latitude value from the climate page. So in that case, the array orientation will change automatically with the climate, but it only changes the latitude, the array tilt angle, and it sets it automatically to the latitude, so that's a fairly limited capability, but in general the answer is no. When you change a location, when you choose a location in the climate list here, all you're doing is telling SAM to read weather data from a different weather file. It doesn't affect any of the other inputs in the other pages. It doesn't change the array orientation. It doesn't change the financing assumptions or incentive assumptions, which of course all may be location specific. So it's up to you to change the input variables elsewhere in the interface when you change the location.